Okay, we are going to find the quotient, and once again, they really like to give us a division, because if it's not division, you just keep it like it is and just multiply straight across. So they want us to keep, change, flip. So we have 6 over 15 times 7 over 1. Can we simplify anything? Nope, there's nothing that 7 and 15 has that we can divide into each one of those. And 6 and 1, well, 1 is already just 1, so nothing for that. So let's just go ahead and multiply. 7 times 6. So 7 times 6 is 42. So that's our numerator. 15 times 1 is 15. All right, that's an improper fraction. How many times does 15 go into 42? Well, 15 times 2 is 30. 15 times 3 is 45. So it's just a little bit too much. So we can do 2. All right, and so we know that 2 sets of 15 is 30. So what's left over? Let's see, 30 minus 42 would be, or 42 minus 30 would be 12 over 15. Well, we're not quite finished yet, because I can see that we can divide something into both 12 and 15. We can divide 3 into both of those. 3 goes into 12 4 times. 3 goes into 15 5 times. All right, so now we have actually simplified it. So the answer is 2 4/5 once we simplify it. All right, that's our answer for that problem. Okay, so Mr. Rivera can grade 8 math tests in 10 minutes. So we can do 8 tests in 10 minutes. All right, so let's just start messing around with equivalent ratios. I know half of 8 is 4. Half of 10 is 5. Half of 4 is 2. Half of 5 is 2.5. Half of 2 is 1. Half of 2.5 is what? Yes, 1.25. Okay, so that's interesting. So we do know the unit rate, as far as that goes, it's going to be 1.25 minutes for one test. Okay, but what if we were trying to find the unit rate per minute? Well, we would have to have that down to 1. Do we have something over on this side that would be easy to get down to 1? Well, I think 10, right? From 10 down to 1 would just be divided by 10. So we would use this divided by 10. Well, all you have to do 8 divided by 10 is just move the decimal over one place to the left. So it would be 0.8. So depending on what they're asking for the unit rate, okay, if they're saying how much time per test, it'd be a minute, 1.25 minutes per test. But if they want to know how much of the test they can do per minute, it's going to be 0.8 of the test. Okay, so, or 0.8 of the test, or 80%, either one, or any of those. So both of those are good answers because they didn't tell exactly which specific unit rate they want. So we found both. All right, so we have how much time per one test right here, and then we have how many tests per minute right there. All right, now we're going to write an equivalent expression. Okay, all right, so that's going to be pretty simple. We're just going to distribute this 8 to everything inside of the parentheses. So 8 times 3 is 24. So it's 24x. Plus 8 times 2 is 16. We have now created an equivalent expression. All right, so that's all there is to that one. It was real simple. You just take the number on the outside and distribute it to everything on the inside. So now those are exactly the same value. If you put a number in for x, they're going to come up with the exact same answer. So this is the exact same value as this. They just look differently, and I think this one's going to be easier to use. So there's your equivalent expression. Draw a number line to represent the inequality. Okay. Well, I know that the number we're dealing with is 20, and I know we're either going to be above or below the 20. So I'm just going to make a number line, and somewhere near the middle-ish, I'm going to put a 20. And I know that this then would have to be 21 and 22 and 23. This would be 19, 18, 17. Okay. All right, so at this point, since we're dealing with 20, I'm going to circle where 20 would be represented on the number line. And then I'm going to just read this and see what it says. Y is less than or equal to 20. This little thing right here means equal to, which means that circle on the number line, should that be open or should it be colored in? It should be colored in because we can include 20 because of that little equal sign on there. And then it says y is less than. So whatever number y is has to be less than 20. All right, so would that be to the right for 21, 22, 23? Are those numbers less than 20 or is it 19, 18, 17? Yes, it is to the left. Okay, so if we were to draw the number line and then graph it to represent y is less than or equal to 20, it would look like this. Okay, it would have the circle right here, colored in, okay, and then it would go to the left, okay, and it would be any number on the number line that goes on and on forever that is less than 20. All right, that's the answer to that one. Andre's backyard is 400 square feet. Okay, so, and it says her rectangular swimming pool is 10 feet by 6 feet wide. What is the area of Andrea's backyard, not including the swimming pool? So we have to subtract out the swimming pool. Okay, so the first thing that I looked at to make my little drawing here to hopefully give you a visual is 400 square feet. So basically the sides, the base and the height has to equal 400. So I could have done like a 40 by 10 yard, okay, or but I did a 20 by 20 because 20 times 20 is 400. So there's my yard here, which is 20 by 20. That's the whole yard. And then here is the pool, okay, and they said the pool is 10 feet long and 6 feet wide. Okay, so there's the pool. Well, we know that the whole yard is 400 feet squared. Okay, so we need to subtract out whatever this is. So what is 10 times 6? Well, that's 60. So the pool is taking 60 square feet away from the total yard. So all you have to do is do 400 minus 60, and that's going to give you 340 feet squared. So the backyard has 340 feet squared available to play around in or do anything else in because they're taking up 60 square feet with the swimming pool. So there's your answer, 340 feet squared. Aiden received these two presents for his birthday. Which has a greater volume? Volume is length times width times height. All right, so I can kind of just look at it. I see that the 10 is bigger than these 8s. Okay, but then there's a small number and a small number, and these are all kind of bigger numbers. So my estimate right off the top is going to be the cube, but let's find out for sure. Okay, so we have 10 times 2 times 3.5, which is actually 10 over 1, times 2 over 1, times, well, 3 times 2 is 6, plus 1 more is 7, 7 over 2. All right, so we can do some cross-reducing before we do anything here. The 2's can cancel out and become 1 and 1. Okay, so the bottom is just 1. And then 10 times 1 is 10. Then 10 times 7 is 70. So on this side, the answer is 70 inches square or cubed, right? That's the volume, length times width times height. And then for the 8 times 8 times 8, well, 8 times 8 is 64. And then 64 times 8 is 512. Okay, so that's 512 inches cubed. Okay, I didn't write that very well, but there it is, 512 inches cubed. So, yeah, my hunch was right. 512 is a much larger volume than 70. So the cube, okay, is your answer. Which has a greater volume? The cube does. Okay, now we need to find the surface area. All right, surface area means we're going to find the area of that triangle there. The triangle on the back, this rectangle, the rectangle on the back side over here, and the base, which is also a rectangle. So we have a lot of things that we need to find real quick. Let's see, 2 more taps. I think we got it taken care of. All right, 1 more. All right, so then let's find that now. So we have the base, which is 7 times 16. So we have 7 times 16, and that equals 112. So right in here is 112. Okay, this side right here is 16 by 7, I guess, as well, right? 16 by 7. So I think they're all going to be 112. So then we just need to find the triangle. The triangle is 7 times 8, right? So 7 times 8 is 56. But we're going to have to divide that by 2, and that gives us 28. So this is 28, and that triangle on the other side is 28. So we're just going to add them all up. We have 112 times 3, which would give you 336, plus 28, which would give you 364, plus 28, and that gives you 392. 392, well, I'm not sure what's going on there. 392 inches squared. Okay, so we're just adding all of those up. 112 plus 112 plus 28 plus 28. 392 inches squared is the surface area of this triangular prism. Okay, so on this last one, we are finding the mode and the range. Okay, we're going to find the mode and the range. But there's some information on here that you need to know, and it's going to be critical, and you're going to use it over and over in the future. Okay, one of them is mean. Okay, the mean is the average of the data set, which means this is 3, but there's 1, 2, 3, 4 3s. So if you were to write the data set out, it would actually be 3, 3, 3, 3. Okay, and then how many 4s are there? Well, there's 3 4s, so they're going to be 4, 4, and 4. And then how many 6s are there? There's 3 6s, so there's going to be 6, kind of going to go downhill here. And then there is 1 9, so we'd have 9 here. So if I had enough room, it'd be 3 3 3 3, 4 4 4, 6 6 6, and then the 9 down there. I think that looks like a 9. Yeah, there we go. All right, so that's our data set. So this is just written out on a number line, and then it's graphed up here with these X's. Okay, and so that's the chart that we'll have to work with. But the mean is the average, which means you would add up all of these numbers and divide it by however many numbers there are, which is 4, 5, 6, 7, 8, 9, 10, 11. So you would add them all up, divide by 11. That's how you would get the mean. The median is the number in the middle. Since there's 11 numbers, we're going to go 1, 2, 3, 4, 5, 6 in. 1, 2, 3, 4, 5, 6. So the number in the middle is the median. And then the mode is the one that happens most often. Well, if you look at the chart here, this happens 4 times. This only happens 3 times, 3 times, and 1 time. Okay, so the mode in this one is going to be 3. And then to find the range, that is the distance from the highest number in the data set. Okay, so there is a 3 as the lowest number in the data set. Sorry, so lowest number is 3. The highest number is 9. So we're going to just subtract those two. So the range is 6, And the mode is 3.